Welcome back. We're looking at another trig identity here. We're going to prove that the left-hand side is equal to the right-hand side. This is example number 4, and I'm choosing on this particular example. I want to show you guys that there's actually two ways that we can prove this particular example. You guys are always hearing me say that, a lot of times in mathematics we can do things a couple of different ways. There's more than one right way to do it, and I'm going to show you guys how to do that on this particular problem. So pull out your trig identity sheets if you haven't already done so, and we'll go ahead and work through this one real quickly. The tangent squared x plus 1, if you look at your Pythagorean identities, you'll see that that's equal to the secant squared of theta. And then we've got cosine squared of x minus 1. You have to do a little manipulation of the primary Pythagorean identity, and you'll note that that is actually equal to negative sine squared of theta. Very important distinction to note there. And actually, we're not dealing with thetas here. We should be dealing with x's. So let's get rid of that theta there. There we go. And no, nobody gets an extra credit point for noticing my mistake on that one. Alright, so I've got secant squared of x minus sine squared, and my goal is to get to negative tangent squared. I'm going to convert the secant squared x to 1 over cosine squared x. Can use the reciprocal identity for that one. And then this is still being multiplied by the negative sine squared of x. Which is, if I simplify this a little bit further, I've got sine squared x negative over cosine squared x. Lo and behold, out jumps at us the definition for tangent. So we'll finish this off. I've got negative tangent squared of x which is exactly what we were shooting for. Alright, that's method number 1. So we started off by using a couple of Pythagorean identities, substituting them in, and ran with it from there. Let's try multiplying these two together. Do a little bit of FOIL and see what we come away with here. So I'm going to have tangent squared x times cosine squared x minus, let's see, if I take tangent of x times negative 1, I'm going to have a minus tangent squared x plus a cosine squared x minus 1. Okay. Well, let's see, is there anything I can do to kind of simplify this? Maybe I can convert things over to sines and cosines here. So I've got a sine squared x cosine squared x over cosine squared x minus sine squared x over cosine squared x plus a cosine squared x minus 1. Okay. Let's see. Maybe use a little bit of algebra here. We can simplify that. So I've got a sine squared. Let's change our terms up a little bit here. Change where they're positioned. And what I want to do right now is I'm going to rearrange these so that I have that minus sine squared x and cosine squared x out front. And take care of that. And the reason I want to do that is because I'm purposefully trying to group a couple of these terms together so that hopefully when you see this, you'll notice that a couple of Pythagorean identities, or one Pythagorean identity in particular, jumps out at us. Alright, so what you should hopefully notice here is that I've got a sine squared x plus cosine squared x in the center here, and that of course is equal to 1. That's our primary Pythagorean identity there. So if I've got those two terms which equal 1 and I'm subtracting 1, I'm left with 0. So I have negative sine squared x over cosine squared x plus 0, which then is equal to only the negative sine squared x over cosine squared x, which is the same as the negative tangent squared x, which is exactly what we were trying to prove. So there you have it, more than one way to prove the same identity. You choose your method, whatever sticks out in your mind. You take a look at these problems and you recognize some kind of trig identity is showing. Go ahead and try it. Use it. If it gets more complex as you proceed, you might want to rethink the first track that you were trying to solve this with. In the meantime, have yourself a great day and look for example number 5.